Next chapter, angles. Angles are used to measure the amount of tan. If you consider this blue line first, we will draw a similar line, but it's colored red. We put it on top of the blue line. And from this point, we will start turning through the red arm. At the moment, there is no turn. We say it's 0 degrees. We classify angles as follows. If we start turning that red arm, we have created an angle, and that angle is an acute angle. Acute angles fall between 0 and 90 degrees. If we keep turning the red arm, all these angles are still acute angles. We get to a point where it's now straight up. We say the lines are perpendicular to each other. We have created a right angle, and that equals to 90 degrees. If we keep turning past the 90 degrees, we are now into the field of obtuse angles, and these are between 90 and 180. So all these angles are obtuse angles. One more extra turn there, we have what is known as a straight angle, and that equals 180 degrees. We can go further around. We are now into reflex angles, and they are between 180 and 360 degrees. We are almost a full circle, and if we continue the next turn there, we are at 360 degrees, and we have turned a revolution or a complete circle. Angles are measured in degrees using a protractor. On many occasions, a protractor has two scales marked from 0 to 180 degrees. There is an inside scale marked in an anti-clockwise direction, as well as an outside scale marked in a clockwise direction. But it doesn't really matter, because even if you have a protractor with a single scale like this one of mine, you just need to know the line on which to place the protractor. In fact, on my part, I prefer this one because there can't be any confusion on the angles or the scale to be used. So generally, when measuring an angle, what you do is put the center of your protractor on the vertex of the angle. And then you rotate the protractor such that the zero line or the baseline lies on one of the lines, and the other line is within the protractor. So this zero line should be on this line. So let's rotate. Alright, that looks just okay. So the baseline is on one of the lines, and the other line is in the protractor. So if I read that, the angle looks like 20 degrees. You can get another angle. Once again, place the center of the protractor at the vertex. We will then place the baseline on the protractor on this line, then rotate it. The angle is 110 degrees. It is an obtuse angle. The other one was acute. One more. Put the center of the protractor at the vertex. Rotate the protractor, and that looks like 81, 82 degrees. And that's pretty much about measuring angles. Let us now look at some relationship between groups of angles. And we start with angles on a straight line. Here are two examples of a group of angles on a straight line. We start with a straight line, and then there may be one or more lines coming to meet at a point on that first line. And the angles formed around that point, specifically in the direction of the incoming line or lines, are called angles on a straight line. The thing is, angles on a straight line add up to 180 degrees. So if you have an obtuse angle 100 degrees and an acute angle x on a straight line, notice that I'm already using the terms we've learned. Obtuse angle 100 degrees and an acute angle x are two angles on a straight line, so they must add up to 180 degrees. We find x. We say 100 plus x is equal to 180. Then x is equal to 180 minus 100, and x is equal to 80 degrees. In another example, we have two acute angles, 20 and 50 degrees, and a third, seemingly obtuse angle, y. We'll find out if it is obtuse or not. All the three angles lie on a straight line, so they add up to 180 degrees. We therefore say 50 plus 20 plus y is equal to 180. Then y is equal to 180 minus 50 minus 20, and y is 110 degrees. And yes, y is an obtuse angle. Next, vertically opposite angles. When two lines cross each other, four angles are formed. The marked angles on each diagram are a pair of vertically opposite angles. On the left diagram, the vertically opposite angles are acute angles, but the right one has obtuse angles, which are vertically opposite angles, even though they may seem horizontally oriented. The thing is, vertically opposite angles are equal. So for these two vertically opposite angles, x is also 50 degrees. In this one, x is 85 degrees because it is vertically opposite to the angle 85 degrees. Angles at a point. What is a point being referred to here? The point is where all the lines meet. So this is the point we are talking about. So when we say angles around a point, these are the angles we are describing. The left diagram has two angles and the right one has three angles. The thing is, angles around a point add up to 360 degrees. So if you have two angles at a point, the reflex angle is 240 degrees and the obtuse angle is x. We can find the size of x. We simply say 240 plus x is equal to 360 degrees. Then x is equal to 360 minus 240, and x is 120 degrees. Then we have three angles at a point, 150, 110, and y. Again, we can find the size of angle y. We say 150 plus 110 plus y is 360, and y is equal to 360 minus 150 minus 110, and that gives us 100 degrees. Next, let us look at some terms that strictly describe a pair of angles. These include vertical, supplementary, and complementary angles. We have seen that when two lines cross one another, there are four angles. Let's label them A, B, C, and D. The angles opposite one another are the same. A and C are the same size. B and D are equal. We have called this pair of angles vertical. Let us focus on the top half for a moment. These two angles form one straight line, 180 degrees. That means A plus B is equal to 180 degrees. Whenever two angles add up to 180 degrees, we call them supplementary angles. I know you're wondering, didn't we just call them angles on a straight line? True. The thing is, the name supplementary comes from the fact that the two angles add up to 180 degrees and not because they are on a straight line. And because of that, two angles need not be on a straight line for them to be called supplementary. No. For example, these two angles are supplementary because they add up to 180 degrees. So you'd say 50 degrees, 60 degrees and 70 degrees are supplementary angles, right? Wrong. Supplementary angles are a pair. They must be two angles and not more than that. Next, let's look at this right-angled triangle. The angle is 90 degrees. Let's call the other two angles A and B. Since the sum of any triangle equals 180 degrees, we have A plus B plus 90 is equal to 180 degrees. If you subtract 90 degrees from both sides, you get A plus B is equal to 90 degrees. Any two angles that add up to 90 degrees are called complementary angles. An easy way to remember this: if someone says something and you completely agree with them, you might say, "You're right." That's much like a compliment, and two complementary angles make a right angle. For example, suppose these two angles are complementary. What's the size of angle B? Next, parallel lines and transversals. Parallel lines are two lines on a plane that do not intersect. They travel next to each other, maintaining the same distance between them to infinity. Notice that the lines are on the same plane. Later, we will see that there are lines that do not meet but are not parallel because they are not on the same plane. Like these two lines, they will never meet but are not parallel. They have a name. A transversal is any line that intersects two lines on the same plane. We will look at a transversal that intersects parallel lines and see the features of the angles formed. So we have two parallel lines and a transversal cutting them, and we have a group of angles all over here. Specifically, there are 8 angles formed. Let us look at the features of these angles. We start with corresponding angles. Again, here are the two parallel lines and the transversal. The blue circles indicate the angles formed. So, what are corresponding angles? Here is a pair of corresponding angles. I can't have one statement to define them, but these two angles are corresponding. An easy way to recognize corresponding angles is to look for an F shape in the line, like this. And it's the angles lying on the corresponding sides of the parallel lines and the transversal. In this case, the angles lie below each parallel line and right of the transversal. Is that the only pair of corresponding angles? No. We can have angles below each parallel line, but this time to the left of the transversal. These are also corresponding angles. We are not done yet. If we go above each of the parallel lines, left of the transversal, a pair of corresponding angles. And lastly, above the parallel lines and to the right of the transversal, another pair of corresponding angles. The thing is, corresponding angles are equal. So if you know how to spot corresponding angles now, it should be clear that 45 degrees and x are corresponding, and so x is also 45 degrees. Next, alternate angles. Again, these are the angles formed by a transversal through two parallel lines. The angles marked are a pair of alternate angles. Let's see another pair so you get the relationship. These two are a pair of alternate angles. Alternate angles are equal, so the trouble is in spotting the angles. So looking at this diagram, the two angles are alternate, and so x must be 45 degrees. Here again, the angles are alternate, and x must be 135 degrees. Lastly, co-interior angles. The angles in our usual diagram, just like the name suggests, co-interior angles are the two angles on the interior of the two parallel lines and on the same side of the trajectory. These two are a pair of co-interior angles. Again, on the left of the transversal, we have another pair of co-interior angles. The thing is, co-interior angles are supplementary. That is, they add up to 180 degrees. So the trick is in spotting which angles are co-interior. And so for these two angles, we can see that they are co-interior. And so they are supplementary. Given that is the case, angle X is 135 degrees.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.